Okay, action. So as I was saying, it's hard to keep perspective on what this cosine function might look like with these values when they all sort of look the same when you look in a textbook or when you look online. So what you want to first start with focusing on is the scales that are used. Okay, so this is scaled vertically. We have our depth, they labeled this as depth on the y-axis, scaled by 3, and on the x-axis they're scaling with integers. Okay, and they're getting very high, very fast. So we're scaling here by 3 as well. So if you look at the cosine wave that we have over there on the board, with a max of 1, a min of -1, and a period of 2 pi, 2 pi as a decimal is a little bit more than 6, right? And if you go to a max of 1 and a min of -1, this is the cosine wave that we've been looking at, that we've focused on in terms of graphing. So obviously, this graph has been altered. It's been transformed. The first couple of things you want to identify are the extremes and the length of the period. But even before that, if they're starting us on the y-axis, we have two choices, right? Even though this says use a cosine model up here, why does it make sense? Why are they telling us this? They're kind of taking it easy on us by saying, here, use cosine. But why are they making us use cosine for this function? Why not sine?
Because it starts at x.
Very good, because cosine waves start at their maximum, sine waves start at a 0 value, at an intercept. Okay, so a sine wave is going to start at an intercept, go up, and then down, and then finish. A cosine wave is going to start at its max, go down, and finish at its max. So when you look at this, if we want to look at x equals 0 as the beginning of the period of this wave, then it's starting at its maximum, then it makes sense to use cosine. Okay, so that's the first thing. Right? We're going to use cosine. Now we've got to fill in the blanks. Obviously, this graph has undergone some transformations. If this is what cosine is supposed to look like, cosine x, this graph, just physically, look at the physical nature of this graph. What's happened to it?
It grew.
Say again?
It grew.
It grew, be more specific.
Stretched.
It's been stretched out. In which manner? Both. It's been stretched vertically to go here instead of here, and whereas the period ended here for our normal cosine wave, our cosine of x, you know, going off of what Joe said, if this is the beginning of the period, where's the end? Where does the period end? Where does one period of this cosine wave end? Think about the definition for period. It's that interval of inputs that it goes through before it repeats all of its behavior. So if we start our cosine wave here, how long does it take on the x-axis before we repeat everything? 12. It takes 12, what do we have, hours. So the period length is 12. 12 hours. Does that make sense? Mm-hmm. Okay. So you probably want to write that down. It's important to identify that the period is 12. And knowing the period is going to help us find what? B. The period is directly tied to that value of B, that horizontal compression or stretching factor, right? So I can use this formula now with this piece of information to help me figure out what B is. It's a formula. All right? The period is 12, and 12 has to be equal to 2 pi over B. So we pull the old switcheroo. Showed you guys this before, I think. If you have an equation where you have an integer or a singular value set equal to a fraction, where the denominator is your variable, you just swap those two things out. So we have b equals 2 pi over 12, and we can reduce the 2 over 12 to be pi over 6. So we have our b value. The b value is directly tied to the period. You need to know the length of the period in order to identify that transformation. And just to reiterate, the period is that interval of inputs, that interval of x values that we pass through as the wave goes through before we see a repetition in that behavior. You've got to know though, part of it stems from knowing that your cosine wave goes from max to intercept to min to intercept to max. So in other words, from maximum point to maximum point. All right? So we've got b. We've got pi, come on smartboard, oh god. That's a pi symbol. Pi over 6 with an x next to it. There we go. We're getting there. Now let's talk about A, let's talk about amplitude. Right? What is the amplitude? The amplitude is two definitions. It's the half the distance from the maximum to the minimum point, or if you can identify that equilibrium value, okay, you can just find the distance from that equilibrium to the max or the min. Now they're really taking it easy on you here. They drew this. So it's sort of like this straddling between the max and the min, this halfway point. Half of the graph is above it, half of the graph is below it. That's kind of the concept of equilibrium, I think. So when you look at this equilibrium value, it's at 9. What is the distance from that equilibrium value to either the max or the min? 3. So our amplitude has a value of 3. And amplitude, I will tell you now and reiterate again, is an absolute value. Now it's possible that this would be negative, but if this was negative, that would be some sort of reflection. So we'd see instead of a wave here from max to min, we'd see it go from min to max. That'll come up in a little bit. And then last but not least, we have that vertical shift. Okay, equilibrium value. Again, this is the x-axis is supposed to act as that equilibrium point, where half the graph is above it and half the graph is below it. Obviously, that's been shifted up. Now again, they cheated. They gave it to you, right? But you can see this dotted line as that equilibrium value. That is how far up we've shifted. One of the tricks to identifying a shift, a vertical shift, is not trying to see how did the entire graph move. It's find a fixed point and say this fixed point moved up 8 units. I know it was supposed to be here, now it's up here, and that got moved up 8. Then you can identify the vertical transformation as 8. Right? So that equilibrium value that was supposed to be the x-axis got shifted up 9 units. So everything got shifted up 9 units. So we have our cosine function for this wave, 3 cosine pi over 6x plus 9. This is, sorry. That x should be inside those parentheses. I don't know why I didn't do that. There we go. That x needs to be inside those parentheses. It has to happen inside the function to x, right? Terrible mistake right off the bat. Change that. End scene.